Okay, so for question 22, where it tells you to, for the Pfizer pen, on the label, it says milliliters diluent added. That just tells the pharmacy, or it tells the nurse how much deionized water to add to the powder. Once that water's been added to the powder, then it will give us the desired solutions, which are listed there as units per ml solution. That's all you need in order to solve this problem. You just need to know which is the most, which one has the highest or strongest concentration, and the strongest concentration is going to be the 1 million units per milliliter. So once you know that information, all you got to do then is take the 750,000 units divided by the 1 million units. I think I did that number of zeros right. Times 1 milliliter, and you'll get 0.75 milliliters. A little also additional trick, choose the least number of zeros that occur in both things here. So if there's 4 zeros here, cross out 4 zeros here. 75 over 100 is easier to put into your calculator than is 750,000 over 1 million, because inevitably mistakes happen.
And then, sorry, if nobody else is asking, will you go over 21?
Sure. Yeah. Ask away, Chris. Not a problem. Yeah. So 21 is going to be the same thing. 21 is just asking you to choose the strongest concentration. So it's basically 21 and 22 are your reconstitution type questions. So the strongest concentration is going to be the highest number per milliliter. So that's 20. So you just take your 60 milligrams divided by the 20 milligrams times the 1 ml for 3 milliliters.
Can you do 16, please?
Absolutely. So 16 is fairly new for you guys this semester, because I don't think you did flow rates last semester when you did, or at least your first semester test. Or you may have done flow rates, but you didn't do flow rates or drop rates. So 16 says that we have a D5W IV solution infusing at a rate of 75 milliliters in 25 minutes. And then what is the flow rate in drops per minute? So what you're going to see here is we're going to go ahead. Well, first of all, I'm sorry. I need to do like a little bit of a intro here. In order to calculate drop rates, you need two pieces of information. You need flow rate and you need the drop factor. Those two things give you a drop rate. The flow rate is typically in milliliters per hour. Sometimes it's milliliters per minute. The drop factor is drops GTT per ml, and the drop rate is drops per minute. The drop factor is always given to you here at Allegheny campus. However, if you're at another campus, or maybe if you see this later on, like on the NCLEX, they'll say that they are using a microtubing. Microtubing is 60 drops per milliliter. So this question says that we are infusing 75 mil in 25 minutes. I'm just going to multiply by my drop factor of 15. We eliminate, and we're left with what we're looking for, which is drops per minute. And then we get 45 drops per minute. Good question.
Can you do 20, please?
Absolutely. So 20 is going to be following the same path, or the same basic concept of flow rate times drop factor. In this instance, now we have 1440 cc's over 12 hours, and we have a drop factor of 10. You know that milliliters and cc's are the same, so you can leave it at that. And when we do this, I'm gonna create an alternative step here, but I'll just show you how to work this through. But before I actually do the equal sign here, I need to do one more conversion, and I need to convert hours to minutes. So if I was doing dimensional analysis and throwing it all out there, this is how you would solve this problem. But I'm going to tell you right now, you could just do like a side step. If you just do 12 times 60 is 720, and that would be minutes. And then so if you substitute these two, 1440 over 720 is 2 times 10, 20 drops per minute. If you don't do the substitution part, like I did the 12 automatically to 720, if you work it out like this, if you do the 720, then you don't need to do this part here. I hope that wasn't terribly confusing.
Okay, thank you.
Yep, you're welcome.
Dr. Rad.
Yes, sir.
So like with those problems, you can do like the drop rate, like since it's 10 drops per milliliter times like the CC, then divide by 12, then divide by 60 and still get the same answer.
Correct. While you guys are still pondering or looking through what questions to ask, I just want to review real quick the insulin syringe, and I posted in that link that I sent in the chat. And if anyone came in after I posted that, just share that link again. But what's going to happen? Well, I'm just going to review this, but this is actually on and listed on the link, and I also did I did this on my YouTube channel as well, so you can see this. So this is our syringe. I think the example I give you is it says to, which syringe do you choose? Which one do you choose? It's usually B, and it's the one that has units listed on it. And then you always do regular insulin first. So regular first. It asks you to make 2 marks, one indicating the total, and then another one indicating where the regular insulin is drawn up first. So in the example that's in your packet, it says 10 units regular, 40 units NPH. You always draw regular first. So 10 plus 40 is 50. So you'd make an initial mark at the 50 units mark. So here's your total. And I would even indicate total. And then you would actually make your second mark at the 40 unit mark, because it's at the 40 unit mark, it's between these two that the regular insulin exists, okay? It's hypothetical, it's not realistic, because once you draw up the regular and the NPH, it all mixes together, but they just want you to try and indicate where those are. From 0 to 40, that would be your NPH. So if you wanted to add that clarification, you certainly could. The other thing is they just want to make sure that you can denote marks on, put arrows on the syringes in the right places. So sometimes you'll see it as like, it'll be like 52 or 54 or 56. They just want to make sure you're able to put an arrow at the correct total mark. And just remember that the regular insulin is going to be closest to the plunger side of the syringe. So you wouldn't do a mark at 10 and then at 50. It would be at 40 and 50. And then, like I said, make sure you indicate what you would draw first, 10 units of regular insulin first.
So the regular insulin is going to be at the 40, 50, and that's where you're going to put the arrows.
Correct.
Okay. Can you go over question 9?
Absolutely. Okay. So question 9, this was, so the first thing I'll say about question 9 is that if it doesn't tell you specifically dose or day, assume per dose. Okay.
Okay.
If it tells you per dose, then you do per dose, and if it tells you per day, you do per day. So for this question, it tells you you have 500 milligrams to take BID, and then how many capsules are you going to give per dose? So if there's 500 is what's ordered, have on hand, that's going to be 2, what are these, capsules per dose, and then you would give that dose twice a day.
Okay.
And if you prefer to see this as a dimensional analysis, 500 milligrams. This is capsules, 250 milligrams, and we'd get the same answer of 2 capsules.
Can you go over 17?
Absolutely. So 17. We're going to do a conversion where we're going to go from milliliters per minute to milliliters per hour. So 120 milliliters in 90 minutes. And then the straightforward way is just convert minutes to hours. Multiply across the top, divide by the bottom, and you'll get 80 mil per hour. Another way that I've seen other students do is they'll just take the 120 milliliter, and 90 minutes is what? 1.5 hours, right? So 1.5 hour. And then you just 120 divided by 1.5, and you'll get the same answer.
Okay.
So there's a couple different ways to do that particular problem. The other thing is, and I always like to add this too, sometimes you might get something like 120 milliliter in like 30 minutes, and it's going to ask for the flow rate in milliliters per hour. You could still do this. Or you can reason through that if you give 120 in 30 minutes, in an hour, you would have given 240 ml. The sticking point is you look at that and you say, how could I infuse more than what I am supposed to give? And that's not the point. The point is you set the rate at how fast you want it to go. So if I want that 120 mils to be infused in 30 minutes or 90 minutes or 45 minutes, you're just changing the rate. The example, the loose example I like to use is, imagine you and I were we were starting at the same point and we were driving to Kennywood. We would, if you're driving an Aston Martin and I'm driving a Honda Civic, you're going 30 miles per hour and I'm going 60 miles per hour. It doesn't matter what the vehicle is. I'm going to get there first because I'm going faster than you are. I don't know why you're going so slow in Aston Martin, but anyways, nor why are you bringing that to Kennywood either. But anyways, the point is, it doesn't matter what the quantity is. It matters what the rate is. And so the rate is what's important. Anyways.
I don't have a question right now. I'm just really happy you mentioned an Aston Martin.
Oh, okay. You're welcome.
Q over 25.
Yes. Okay, so with number 25, it tells you that the order was 500 micrograms of the medication, and that what's available is 0.05 milligrams per milliliter, and we want to know how many milliliters to administer. The trick to this question is you cannot do math if they're in two different units. So you have to convert micrograms to milligrams or milligrams to micrograms. And it really doesn't matter which one you do. So you get to choose. Since I'm the one doing it, I'm going to choose the first thing. So I'm going to convert the 500 micrograms to milligrams. And that ends up just being 0.5 milligrams. So all I did was move my decimal point over 3 to the left. The other way you could have done that is you could have divided by 1,000, and you get we all get to the same answer. Once you have that 0.5 milligrams, then you just divide by what you have available times the 1 mil, and you get 10 milliliters.
Can you please go over 22 again? I'm trying to do it on my own and it's not making sense.
Okay, sure.
Thank you.
So the trick with 22 is make sure you ignore the milliliters diluent added. So when I'm doing 22, I ignore that whole column of milliliters diluent added, and I just focus on the units per milliliter solution. It tells me 750,000 units is what's ordered, and to use the strongest concentration. So I just take the 750,000 units. I think I did that. Nope. Yeah, 750,000 units over the 1 million units times 1 milliliter, and you get 0.75 milliliters. And then the other trick is there's 4 zeros here and 4 zeros here. Eliminate the same number. 75 over 100 is much easier to plug into your calculator, and you're less likely to make mistakes.
Can you go over 10?
Yes. All right, so first of all, on 10, so 10 is a lot like the one we just, like 25, where you got to make sure you convert either grams to milligrams or milligrams to grams.
Yeah.
10 also, you got to make sure you mark the cup. So don't forget to do that. The nice thing about the cup is you know that the answer is going to be on the cup. So that's a little bit of a shortcut for you guys. So we have 0.35 0.375 grams. And I'm going to convert that to milligrams, so it's 375 milligrams. And all I did was move the decimal 1, 2, 3 to the right. And then, of course, you could have just did a conversion, multiplied by 1,000, and you would have the same answer. Once you have the 375 milligrams, then you could, if you're doing ordered over half, it's 375 over the 125, and then this time it's times 5 ml. Always pay attention to what the per milliliter is, and then you get 15 mil as your answer. If you're going to do this dimensional analysis wise, 375 milligrams times the one, we don't want the milligrams, we want the milliliters, and you get the same answer, 15 ml. And then, like I said, make sure you find the 15 ml on the cup. 15, and says to circle your answer or indicate it however they tell you to indicate it.
And this is a 70 question exam, so it's going to be the same format of questions, just repeated, right? Like there's no other format of question that's going to be on the exam that's not on the practice.
How many questions did you say?
We were told 70.
From what I understand, there's 25 questions.
Okay.
And then it shouldn't look very similar to this test. I'm the original author of the tests and the practice tests, but I know that the instructors do change them up, but they should follow a similar format.
Okay.
Yeah, the link, I'll repost it for you. If you came in late, it's not there anymore. So there you go. All right, so 16. And we did do this one already, but I'm glad that you asked so we can do it again. That's what we're here to do. So when I talked about 16 before, I always said you need to make sure you know two pieces of information. You need to know the flow rate and you need to know the drop factor. Those two pieces of information will give you the drop rate. Flow rate is typically milliliters per hour. Drop factor is going to be drops per milliliter. And that at Allegheny campus, that will always be given to you. It'll be on the label or be written in the question. If it's an NCLEX question or if you're at another campus, a lot of times they'll use microtubing, and microtubing is 60 drops per milliliter. The drop rate then becomes drops per minute. So the only thing you really need to do is convert hours to minutes unless it's already in minutes. So like question 16, you have 75 milliliters, 30 minutes is your flow rate. Your drop factor is 15. I'm sorry, 25 minutes. Your drop factor is 15. And then you know you've set it up right because you're left with what you're looking for, which is drops per minute. And that equals 45 drops per minute.